This is the video for the topic number 4 test review homework. Number 1 gives you some data in a table, and the first thing it wants you to do is create a scatter plot. So here's a scatter plot. I have the horizontal x-axis labeled and scaled the way they wanted, and same with the vertical y-axis, and the blue marks are all the points from the data. Part B asks for means and standard deviation for both the x and the y. So the x bar, the mean for the x coordinates, is 4. The standard deviation for x is 2.58. The mean for the y's y bar was 30, and the standard deviation for the y's was 4.78. So all this is found in your graphing calculator. You enter your x coordinates under list 1 and your y coordinates under list 2, and then you go into stat and 2 variable statistics. Part C wanted you to plot the mean point x bar, y bar, so 430, and label it L, so that point would be right here on your scatter plot. Part D wanted you to find the correlation coefficient in 1. There's 2 ways you could do that. You could do it by hand with the covariance divided by the standard deviations of x and y multiplied by each other, in which case you'd end up with 0.987. Or you could find the linear regression and do it in your calculator, in which case you get R to be 0.986. Either way, load and length are strongly correlated. He asks you to find the linear regression, so using your calculator you get y equals 1.83x plus 22.7, and then part F asks you to graph it. Make sure when you graph it on your scatter plot you go through the y-intercept and you also go through the mean point. Whenever you graph a linear regression on your graph, it always has to go through that mean point. Part G, you would plug 5.4 in for x. You can do this in your equation and you end up with 32.6 centimeters. Or if you look on your graph, you could go up from 5.4 and then whenever it hit your regression line, go over and you end up with about 32.5 centimeters. So either of those would be correct. Part 2, 30 kilograms is outside our data range of 0 to 8. So we cannot accurately predict anything at 30 kilograms. So you couldn't use your equation to predict something outside of 8 kilograms. Part A, for number 2, asks you to find a linear regression. So again, you plug in the age or your x coordinates in for list 1 and the number of objects remembered, your y coordinates, in for list 2, and find your linear regression, and you end up with y equals negative 0.134x plus 20.9. For part B, they want you to figure out the estimate of the number of objects remembered by someone who is aged 28 years, which is your x coordinate. So plug it in for x, you get 17.148. Since objects are discrete, you would say 17 objects. Correlation coefficient, again, you should have gotten that when you got your linear regression up here. So you end up with negative 0.756. Because that's below 0.8, we would say there's a moderate negative correlation between age and objects remembered. Number 3, they tell you that x is normally distributed with a mean of 45 and a standard deviation of 9. So this is how we would write it in that R notation. And we want to find the probability that your value falls between 28 and 66. Make sure you always draw your little normal sketch to start with. So we have our mean at 45, and we want everything between 28 and 66. Plug it in your calculator under distribution, normal CDF, and you end up with 0.961 or 96.1%. Number 4 is talking about the probability of cats' weights happening. So they tell you that it's normally distributed with a mean of 3.42 kilograms and a standard deviation of 0.82. So that gives you this notation right here. And then they ask you what percentage of cats will weigh within 1 standard deviation. So that's something that you could just have memorized. Otherwise, you could set up the probability. But either way, you end up with 68%. And then the number of cats that will have that surgery will be 150 of the total times that 0.68, so 102 cats. Part B asks us to draw a little normal sketch for the probability that cats weigh less than 2 kilograms. So we have our 2 here and we want less than. So then part 2 says actually calculate that probability. So x is less than or equal to 2. Plug that in your calculator. Again, normal CDF under distribution. You want your lower bound to be negative 1e99 or something really, really, really big in the negatives. And you end up with 0.042 or 4.17%. Part C asks the probability the cats weigh between 2 and 4.8 kilograms. So again, draw your normal curve, shade everything in the middle, plug it in your calculator, and you end up with 0.912 or 91.2%. The last part says that the probability that the cats weigh more than a certain weight W is 0.025%, and they want us to find what that weight W is. So we set up this little notation here, and we drew our picture to go with it. Our calculator will only do less thans for these, they won't do greater than, so we have to figure out, okay, well, if the probability that the cat weighs more than W is 0.025, then that means that the probability that the cat weighs less than W is 0.975. So then you plug this in your calculator under distribution inverse normal, as this is the area, and you end up with W is 5.03 kilograms. Number 5 is a chi-squared test. So first, I always write down my null and alternative hypotheses. For in this case, the null hypothesis is that the political party is independent of age. Remember, null is always independent. And then alternative is always not independent or dependent. So political party is dependent on age. So they tell you your critical value. There's two ways you can answer this question, whether or not you're going to reject the null hypothesis. So either way, you have to put your data into a 3x4 matrix in your calculator and do a chi-squared test. If you read off, you get a p-value of 1.52 times 10 to the negative 23. So that means a decimal point and then 22 zeros before 152. That value is less than your alpha level of 0.05 because they tell you a 5% level of significance. So this is less. Remember, p is like petite. We want it less to reject our null hypothesis. Or from that same screen on your calculator, you could get your chi-squared test value, which would be 120.1, which is bigger than the critical value they tell you of 12.59, so again, reject your null hypothesis. This is an either or. It doesn't matter which one of these you choose to do, just one of them. Either way, you end up rejecting your null hypothesis. So number 6, again, is chi-squared. Part A wants us to write down our null and alternative hypotheses. So our null hypothesis is that TV genre is independent of gender. An alternative hypothesis is that TV genre is not independent of gender or is dependent on gender. Part B wants us to find the expected frequency of the number of females who had comedy as their most watched program. So again, expected frequency is, given this data that we collected, the total number of females and the total number of people who said they watch comedy, what would you expect that combination to be? So you find expected frequency by row total divided by, or times column total divided by your total number of responses. So in this case, 365 times 217 divided by 751, you would expect that 105 females would say that comedy is their favorite. Part C, you use your calculator and you create a matrix, in this case a 2x4 matrix in your calculator, and do your chi-squared test. You end up with your chi-squared value to be 12.6. So last part, part D, number 1 asks you to find the degrees of freedom. Degrees of freedom is number of rows minus 1 times number of columns minus 1. So in this case, 2 minus 1 times 4 minus 1, which ends up being a 3. And then part 2 asks you to actually answer the question, how are we going to reject or not reject the null hypothesis, and what does that mean? So our p-value we calculated when we did our chi-squared test is 0.006, so that is less than 0.05, so we're going to reject the null hypothesis. That tells us our conclusion is that TV genre is dependent on gender.